So here we are going to talk about how to develop hypotheses and understand the conclusions that you can get from a hypothesis test. Okay, so first of all, what's a hypothesis test? A hypothesis test is, once again, another way of being able to take information from a sample and make an inference or a guess about a population. So we've talked about this before with confidence intervals. Now we're going to go about this in a slightly different way with hypothesis testing. So the first step to hypothesis testing is to know how to construct your hypotheses. Okay. There are going to be two different types of hypotheses. We have what's called an H null, the null hypothesis, and then we have the alternative hypothesis. Okay. So the null hypothesis, the analogies we often use is that the null hypothesis is similar to a situation where in the court of law, we say anytime that a person is arrested that they are presumed innocent until proven guilty. Well, the null hypothesis, the H sub 0, um, is a presumed hypothesis, meaning this is a hypothesis that I am going to stick with unless you prove otherwise. Well, what's the otherwise? The otherwise is the alternative hypothesis, which is listed as an HA. As far as mathematically speaking, how do we know which one is which? Well, H null, the null hypothesis, will always have an equal sign with it. So it'll always be either an equals to, a greater than or equals to, or a less than or equal to. And I'll explain those in a little bit. But then the alternative hypothesis will be the opposite of those signs. So an alternative hypothesis will either be a not equals to, a greater than, or a less than. All right. So as a note here, look, your H null always will have an equal sign. Your HA will never have an equal sign. Okay. And going back up a little bit, when it comes to hypothesis testing, you'll collect some sample information and you'll perform the hypothesis test. Your decision is that you're going to either reject the null hypothesis or you're going to decide that you should not reject the null hypothesis. So those are the two decisions when it comes to hypothesis testing. Here we go. Suppose you want to test whether a college student takes less than 3 years to complete a 2-year degree. What are the null and alternative hypotheses? Okay, so as you'll see with a lot of these problems is that once you read a problem involving hypothesis testing is that you'll quickly see that they're only going to give you one hypothesis. And in this case, we're trying to test whether a college student takes less than 3 years to complete a degree. What that means is we're trying to test if the mean amount of time to complete a degree is less than 3 years. Okay? That strictly less than means that is the alternative hypothesis. Remember, the HA does not have an equal sign with it. Well, keep in mind, whenever you test hypotheses, there's two things that can happen. Either the mean amount of time to complete the degree will be less than 3 years, or think about it, what's the other thing that can happen? Well, the other thing that can happen is, well, it could take them greater than or equal to 3 years to complete the degree. So in this case, the H null will be mu is greater than or equal to 3. So only one of your hypotheses will include an equals to sign. And also too, with the null hypothesis, there's actually a couple different ways you can write your null hypothesis. In this case, you saw that I took the complement of my less than to get the greater than or equal to. But what you'll see oftentimes, and you'll see me use this for the rest of the video, is that the null hypothesis can always be written as just an equals to sign. And you'll see why later in the video, because it's the alternative hypothesis that really plays a major role in the determining if you should reject H null or fail to reject. So from here on out, you'll just see me automatically write my H null as an equals to. Here's another one. Suppose you want to test whether the mean salary of nurses is different than $45,000. What are we testing here? We're testing if mean is different. Different means not equals to 45,000. That is our alternative hypothesis. And so what's our null hypothesis? You're always going to have one alternative, one null. Well, the null hypothesis will be, well, either the mean is different than 45,000 or the mean equals 45,000. And there's our two hypotheses. We have the null and the alternative. All right, so what's so important about the alternative hypothesis? Well, that the alternative hypothesis actually tells you what type of test to conduct. And what I mean by that is that you're going to either conduct what's known as a one-tailed test or a two-tailed test. In the picture here that you can see is that let's suppose our HA was our parameter, that's what the P means, is not equal to some number. So P sub 0 just means some number. Well, what that means is that we're going to, this is called a two-tailed test. And what that means, it doesn't make a whole lot of sense right now, but what that means for us is that if you come down to the graph here, that means that as we go, as we try to calculate something that's called a p-value, which is the area underneath our normal curve, we're going to actually look in both tails. We're going to look in two tails to calculate that area. So the total area when the HA is a not equals to will be the area combined in both of those tails. Hence the name two-tailed test. Well, what if the HA is something different? Well, now you get into one-tailed test. In the example here, if your HA happens to be less than some number, notice we call this a left-tailed test because look at how the arrow is pointing. It's pointing to the left. So that means we're going to calculate the p-value will be just the area in the left tail. And in a similar fashion, I forgot to write it, but what if we have a right-tailed test? Let's see what that would be. So I guess the third case would be, what if our HA was P is greater than some number P0? Well, that will mean normal distribution. What that means is that now, grab a different color, is that this is now a right-tailed test. So now this shaded area, the green shaded area, now becomes something that's called a p-value. And a p-value, which is a probability, so it goes between 0 and 1, very important, is going to help us make our decision. And remember, our decision is either we are going to reject the null hypothesis or we are going to fail to reject or do not reject the null hypothesis. And so how do we know how to make that decision? How do you know when to reject the null hypothesis or fail to reject? Well, to do that, it's based off of comparing that p-value to something called alpha. Okay, so what's alpha? Alpha is the probability of what's known as a type 1 error. So what is a type 1 error? Well, just an error in general is whenever you make a decision about something, but it's not actually true. For instance, a type 1 error is the case where you reject H null when in fact H null is actually true. And what I mean by that is that you're saying that, look, I'm rejecting H null. I don't believe H null is the correct hypothesis. But you did that when in fact H null is actually true. That is an error. You're supposed to reject H null when H null is actually false. But anyways, alpha is the probability of a type 1 error. Okay, so alpha is also called the level of significance. Okay, so how do we make a decision? How do we make a decision? So it turns out that if your p-value, so remember it's either going to be a two-tailed p-value, a left tail, or a right tail. If that p-value is less than or equal to that alpha is the probability of you having an error. You want that to be small. But if your p-value is less than or equal to alpha, then your decision should be you should reject the null hypothesis. Okay? What does that mean? If you want to make an analogy with the courtroom, this means that, let's say H null is a person's innocence. In order for you to reject a person's innocence, you have to have a ton of evidence. Or that means that your evidence has to be so tight there's not a reasonable doubt. It has to be less than an error. So if your p-value is less than your error, then you can reject H null. However, if the p-value ends up being greater than alpha, then you do the other decision, which is you're going to, I like to say fail to reject, but you saw earlier said do not reject, but same difference. You fail to reject the null hypothesis. This is your decision rule, and go ahead and learn it now because it's going to play a very important role. All right, so kind of wrapping this up, we're getting kind of close to finishing this up. But what are the steps to a full hypothesis test? The first step is construct your hypotheses like we did earlier. Your next step is decide on your alpha. Well, this will be given to you, so don't worry about that. Alpha will be given to you in the problem. The third step is that you need to compute something that's called a test statistic. So it turns out that your p-value is actually the area in either the left or the right tail with respect to this thing called a test statistic. So a p-value is the probability that you are either to the left of this z-score or to the right of the z-score, or whatever you may have, depending on what type of test you have. The fourth step is now, ignore this right here. We're not going to do this. We're not going to do what's called a rejection region. But find the p-value. As I told you, the p-value is the area either to the left or the right, or maybe in both tails, with respect to your test statistic. And the fifth step is that you interpret the results of this hypothesis test, and we will cover that in a later video. So right now I wanna do a problem where we figure out how do we calculate a test statistic for a hypothesis test of a population mean. Here we go. So it turns out, I'll spare you the details, excuse me. It turns out that the test statistic, I'll just call it test stat. So the test stat for a hypothesis test involving a single population mean when the standard deviation is known. So this is very similar to what we did for confidence intervals. When you know the population standard deviation, it's going to be a z distribution. If you do not know the population standard deviation, it's a t distribution. But here let's assume that we know the population standard deviation. Well, it turns out that your test stat will be a z-score, which will be your x bar minus this mu naught, I call it mu naught, mu null if you want to call it, over the standard deviation divided by the square root of n. Okay, so what's x bar? X bar is your sample mean. Mu naught is what we refer to as your hypothesized mean. All that means is that mu naught is the number that you grab from your hypothesis. What's next? We got sigma, which is our population standard deviation. And n, good old n, is a sample size. So look, to calculate your test statistic, you just read the problem, pull out the appropriate details, and throw them into the formula. Here we go. Suppose a skateboarder claims that his jump height is more than 8 feet on average. Several spectators do not believe him, so the skater decides to do a hypothesis test at a 5% significance level to persuade them. He makes 10 jumps. The mean height of the sample jumps is 10 feet. The skater knows from making hundreds of jumps that the standard deviation for the height is 0.5 feet. What is the test statistic, which will be a z-score, of this one mean hypothesis test. So this is the one mean hypothesis test. So here we go. So the first step, always with hypothesis testing, the first step is to write your hypotheses. We are testing his claim that the mean height of his jump is more than 8 feet. So we are testing the claim that the mean is more than 8 feet. Otherwise, his mean height will be either you could put a less than or equal to 8 here, but I'm going to go ahead, as we discussed earlier, I'm just put just an equals to here. So the equals to is our null hypothesis. The mean is greater than 8 is our alternative hypothesis. Okay. So now we have our hypothesis. We can now create our test statistic, which is z equals x bar minus mu naught over sigma divided by the square root of n. Okay. X bar is the sample mean height. So x bar is not 8. It says that he makes 10 jumps. The mean height of the sample jumps, I'm right here. The mean height of the sample jumps is 10 feet. X bar is 10 feet for this. So our z-score will be 10 minus the mu naught comes from the hypothesis. So in our hypothesis, you see a number 8. So that's why mu naught is 8. So it's 10 minus 8 over our standard deviation. Well, the skater knows from making hundreds of jumps that the standard deviation for the height is 0.5 feet. That's our population standard deviation. And we divide that by the square root of n. What's n? How many jumps did he make? He made 10 jumps. Over 10. So now it's just a matter of us putting this into the calculator. So let me see if I can pull up my calculator. I'll do this. 10 minus 8, close parentheses, divided by, open parentheses, our standard deviation of 0.5 divided by the square root of 10. Because that was the number of jumps that he made. Root, hit enter. And to 2 decimal places, let's say, we get a z-score of 12.65. And so that is our test statistic. All right, see you in the next video.